Um, so I'm actually not exactly sure what these type of threads are called, but the effect is that when they are tightened all the way, you can have surface markings that line up. I would just call them aligned or matching threads. I'm not sure if that's correct though. Um, so the question is, how do we get this to happen? I created this simple object here to demonstrate this. So first, we will go ahead and create a thread on both pieces. I already picked a reasonable size here. And the other piece, we have a matching thread. So let's go ahead and look at the section analysis. So a side note here is this is not when the thread will lock. It will keep turning past this point until there is contact between the surface and the surface. But also, let's go ahead and make this a little bit longer to give a little bit more of a tolerance. I mean, this side can actually go as far as you want, essentially. I mean, this we can thread the whole full length. This should not affect the way that, I mean, when the thread locks. So experimentally, I found that when the thread locks is when this surface and this surface have a distance of about 0.087 millimeters, and that would be between this surface, these two surfaces here as well. So we can do this by rotating this one of these pieces. So we can see we rotate this as we rotate this, these two surfaces get closer and closer. So, oh, whoops. Okay. Minus 10, minus 20. So let's say we do minus 25. Then we can inspect the distance between here and here, and that is 0.11. So unfortunately, you can't do the inspect while you're in the middle of editing a feature. So you kind of have to just do guess and check to get it right exactly. And I've already found that rotating this by about 27.5 should give you the perfect distance. Well, actually, it should probably be a little bit more. So we can try 27.7. So that's about 0.087 millimeters. And we'll go ahead and modify this surface here as well. So now the thread should lock when this happens. It should be pretty tight. Now let's turn off the analysis, and we can see that we want to move this move this feature back to the front position where it's aligned. So we can just go ahead and take this feature and move it past when we rotated it, past the rotation, or we could have moved the rotation before the feature as well. Either way works. And then we can look at our analysis again, and I mean, nothing should have changed. So this is when the thread will lock, and we have our surface markings that are aligned. One thing that I forgot to mention was that this distance, this 0.087 distance or tolerance, is intended for 3D printing. So if you're machining the threads, I would imagine this value being less than what they are here. And the 3D printing that I tested was using a load spot. So I have a bit of a more interesting object here, and we have the same goal of getting the surface features to line up when the threads are completely tightened. So let's look at the cross-section analysis. We see that these two threads, these two parts are threaded together, and these two parts are threaded together. So let's start with this top part. So this is what we'll do is thread this piece and then align all the other pieces to this piece. So this should be pretty straightforward. We just go ahead and make this thread. And one thing to note is that, well, two things to note. One thing is that when you thread this surface, the diameter of the surface actually changes. So if you want the inside piece to be of a certain size, what you can do is just do extrude or press pull, sorry, modify press pull on this surface. And then other thing to note is when you thread this piece, because there's this chamfer here, you get a undercut. And there's this protruding section that will block the thread from sliding past. So what you can actually do is just click this face and click delete. And now you see that that section is removed and the thread can start from here. So let's go just change that back. So then there is the piece that slides in here. So as I said before, when you thread the surface, that actually changes the sides of the surface. So what I did here is created the sketch and revolve, which we will thread. And then there's also the small offset here, and I'll explain the reason for that in just a second. So then we see that the surface, that for this thread, this this interface is actually more narrow than the rest of this cylinder. And what we can do is just to modify press pull. So we're on this one, and get it to just about match up to the rest of this object. So 32.4, and this is 32.48, so that's about the same. Oh, and again, so the reason for this little offset is to create this tolerance between the two pieces. So as you can see again, the distance between here and here between these two surfaces is 0.087. And to do that, you can control essentially how Fusion 360 decides to make the threads by changing this little offset here. So if we start with, say, 25, we see that this should be moved up a bit. So let's do 25.5. We measure. We see that we can use a bit that a little further up would get this closer to 0.087. So we will go ahead and change this. And as I've already found, that 0.533 will get the perfect distance here. Oh, so I guess one last thing to note on the outer piece is that to create this distance here, to make this distance 0.087, you can just go ahead and extend the thread of the outside piece. So instead of, say, 25 millimeters, we have some extra distance to make up for that. So one last piece to look at, and that is the joint between these two pieces. So again, this is kind of like the first example where we want to rotate the piece so that the features match, and then make these features. So first, we just make the threads. And then again, this piece has that chamfer undercut problem. So we can just go ahead and delete those two faces. And then that threads the rest of the surface. Let's turn on this inner piece. So we see without the rotation, here's where we're at. Then we're going to rotate. And I think I made a little bit of a offset there so that this surface and then this surface 0.087, and then this surface and this surface about 0.087. So then after this, we can go ahead and make the extrudes. And well, there it is. So again, the real trick here is pretty much just to play with whatever you have control over to create this distance between the two mating threads.